Okay, let's get started. Welcome to UW-Platteville Chemistry webinar. My name is June Lee, and I'm the chair of Chemistry Department. And thank you for taking time out to be with us today. So let's begin with introduction. Dr. Cornett, you go first.
Hi, I'm Chuck Cornett, Department of Chemistry. I coordinate and supervise criminalistics emphasis within our department. So my specialties are analytical chemistry and radionuclear chemistry, along with forensic chemistry.
Dr. Jim Hamilton.
Hi, how are you? I'm Jim Hamilton, and I'm in the chemistry department, and I am a physical and analytical chemist, and we do a lot of research with students. It's very nice to meet you.
Dr. Raja.
Sorry, my computer was glitching. My name is Dr. Raja Manamalai. I am an organic chemistry professor. I do research in the synthesis of interesting organic compounds, and I teach organic chemistry and general chemistry.
So next is Dr. McKenzie.
Hi, I'm Dr. Ian McKenzie. I am also an organic chemist, but I do primarily organic photochemistry. So to make new reaction development, things like for new medicinal purposes or drug molecules. I also teach kind of a menagerie of things. I teach our polymer chemistry course, so things dealing with plastics, and I also teach our environmental chemistry course.
So we also have 3 of our students here, and Sherry, you go first.
Hi, I'm Sherry. I graduated from Platteville in May 2019, and now I'm in my 2nd year of grad school at University of Illinois, Chicago.
Okay, thank you. Riley?
Hi, I'm Riley. I am a ACS chemistry major graduating this May, and I'll be going on to graduate school at Penn State.
Thank you. And Stephanie?
Hi, I'm Stephanie. I'm currently president of the Alchemist Club, the chemistry club at the university. I will be graduating this May with a chemistry degree math minor, and I'll be going to Oregon to get my master's in polymer science.
Thank you. So feel free to ask questions during this process, and we are here and we are happy to help. So next, we are going to talk about our program, and we have 6 chemistry degree options. And so chemistry degree, chemistry ACS certified, biochemistry, which is also ACS certified, and we also have a biochemistry and biotechnology, which is a new degree options. This new degree options, you do 3.5 years in Platteville and 1 semester in Medicine Area Technical College, which is a very extensive hands-on program there for 1 semester. And you basically learn how to use many instruments there. So when you graduate with this degree option, you get the bachelor degree in UW-Platteville, also the certification of that program. So with that certification, the job placement rate is very high. So that's just the new program. So being a chemistry major, you have many research opportunities in chemistry department. You have opportunities to attend conferences with professors and giving presentations. And you also have internship opportunities. you have work opportunities in the department. And after graduation, you can either go work in a pharmaceutical company, being an analytical chemist, like lab manager, and many other possibilities. But majority of our majors are criminalistic majors. These two popular degree options are criminalistic ACS certified, criminalistic DNA track. I would like Dr. Cornett to talk about criminalistics because he's the one in charge of this program. Chuck, do you want me to stop this? You can. You are muted.
Here we go. Sorry about that.
Okay.
So yeah, I'll talk a little bit about our criminalistics emphasis here in the Department of Chemistry. So as June Lee mentioned, we do have two different tracks. One leads to a degree that is also certified by the American Chemical Society. So it's a little heavier in chemistry and runs through Calc 3 on the mathematics side of things. We also have a DNA track that I'll explain here in just a second, but in general, it's a little less calculus and a little more biology, some upper level biology courses culminating in molecular biology. So one big question students often have here at the university, we also have a forensic investigation program that runs a pair of emphases, one being crime scene, the other being the laboratory emphasis. And it can often be a little confusing about which is which when it comes to the FI lab emphasis and comparing it to our criminalistics emphasis in chemistry. The short story is that there's an organization called the American Society of Crime Lab Directors, and they have a lab division which accredits all state, federal, regional crime labs. And to do the work in there as a criminalist, working in those units, the chemistry degree is preferred. And so when we talk about that, well, we actually see our units within a, let's say, full service lab that do a variety of tasks. So one unit may be controlled substance identification, another may be the trace unit that focuses on ignitable liquid analysis or doing the microscopy on fibers. And a third is the toxicology unit. Now, all of these units, if positions are offered, can be a career that somebody with either of our tracks seeks and is fully qualified to apply for. We also have, with the DNA track, the added benefit that students completing an ACS, or excuse me, a DNA track degree are capable of also applying for DNA analysis jobs, which predominate employment in the crime laboratory. So these are the key careers that you have to have a chemistry degree to get in the door in a certified ASCLD lab. However, with our curriculum, we also have alumni who have been very successful in the other three major units in a crime lab, being fingerprint or latent print identification, also question documents, looking at handwriting, ink composition, things like that, as well as firearms identification. However, most of our students who are looking for career opportunities in those areas are definitely going to be looking at double majoring or minoring along with our forensic investigation program. Now, as Dr. Lee also mentioned, we do have an internship program. The internship is part of our curriculum requirements. So our traditional partners, we often have several people with one of these labs or several of these labs given the summer. And that's the time frame in which students tend to intern. Here in Wisconsin, we have the Wisconsin State Crime Laboratories, We also have students who are alumni of the Minnesota BCA, or Bureau of Criminal Apprehension program. The Iowa DCI in Ankeny, Iowa also hosts some of our interns, as does the Illinois State Patrol in many of their different locations. We also have a thriving, vibrant relationship with the Florida Bureau of Fire and Explosive Analysis. We tend to see 2 or 3 interns down there each summer. So that is the highlight there, and I'll turn it back over to Dr. Lee.
Okay, thank you, Dr. Cornett. So I think a student here would like to know the experiences of our students here. So I would like to ask a few questions for 3 of our students here. So the first question is, what do you plan to do when you graduate? And for Sherry, you may also want to talk about what you are doing now in graduate school. Okay, so Sherry, you want to go first?
Yeah, sure. I will say, I really enjoyed like all the lab experience I got at Platteville, like compared to other bigger universities, because even some people who went to, kind of like the top schools, they in undergrad didn't even know how to do UV vis measurements. They didn't get to do HPLC hands-on in their labs, for example. And I feel like we actually have really good instrumentation for even how small our department is. And we have a lot of really good resources as well. So yeah, I would say that really makes you stand out. And also, when someone sees Platteville, they're kind of like, oh, what is Platteville? Because it's, smaller. Whereas if they see Madison, it's kind of the same old. So it kind of gives you an edge. And yeah, so anyways, so currently I'm going for my PhD, and I'm doing inorganic / biochemistry, kind of a mix. So I am making these supramolecular cages with peptide scaffolds to enhance drug delivery for tumors to help with the selectivity. Yeah, but still, I do miss Platteville though. So, like, I really miss like the small environment for sure. It's a lot bigger, but yeah, nothing but positive from the chemistry department. Like, I really loved being there, and yeah, I think it really prepared me for going to grad school. So yeah.
Okay, thank you, Sherry, for taking time out to be with us today.
Yeah.
Okay. So Riley, what do you plan to do after graduation?
So I started as a double major in forensic investigation and chemistry with a criminalistics emphasis. But after doing some hands-on research with Dr. Rabbani, who's another one of our professors who's not here tonight, and also through my employment with TRIO Student Support Services and Centerpoint EMS Student Success Programs, I realized that I really enjoy working in a higher education environment and working with other students, and that I also didn't want to leave the sort of research laboratory after graduating. And so I recently signed an offer at Penn State to pursue a PhD in chemistry. I'm thinking about going into computational chemistry because I've recently discovered I have an interest in computer programming. So computational chemistry is the use of software and mathematical modeling to predict what chemical systems might do without having to actually use chemicals and run the experiment. And so so I want to pursue my PhD and then pursue a career teaching at a small university like UW-Platteville. I really enjoy the small environment. In the same way Sherry said, I have the opportunity for a lot of hands-on experiences, and also you get to build really amazing personal relationships with professors and with staff that you wouldn't get to at a larger university.
Thank you, Riley. Stephanie?
So when I graduate this May, I will be going to Oregon to get my master's degree. But if I wasn't doing this, unlike my other peers, I actually want to work in industry. I'm not interested in academia as much. And so I am pursuing this master's degree only in that it will help me get an edge in industry. The reason why I want to work in industry so much is that I was afforded a lot of opportunities through Platteville to work in a lab. And that's probably the thing that sticks with me the most about Platteville is, like Riley and Sherry have already said, like you know, you get all this lab experience, but you also know these people, but now they're like, oh, you should try this thing, or hey, you should do this thing. And now you're getting so many new experiences. So you're leaving college not only with a degree, but with like a pretty nice resume as well. And I think that is the biggest perk for me, is that I'm not just leaving with a degree, I'm leaving with a resume. And this resume has helped me get into an expedited industry program, basically. So, you know, I'm the president of the club, I do research, I work on campus. There are so many opportunities for you to grow. And that's what stands out to an employer, not your degree, because you have to be here for your degree regardless. It's the stuff you do in your free time, so to speak, how you grow as a chemist outside of the classroom. So that's what I plan to do when I graduate.
Thank you, Stephanie. So actually I planned 3 questions, and then actually all of you actually kind of answered the second question already. So I just jump to the third one. Tell us the most memorable time in chemistry department. So we'll go first. Sherry?
Yeah, I'm actually trying to think. Yeah, in terms of it, I guess I'd probably have to go when I did research. Yeah, so I researched with Dr. Shoma Charupadai, but she's not here. But, you know, and Stephanie also, she learned under me in research, but I remember just really like kind of enjoying the out of classroom lab experiences and researching. And then, you know, also I got to go to like the engineering building and use instruments in their clean room, which are really cool. And that's something itself that most undergrads haven't used, an AFM or an SEM, for example, which are really more advanced spectroscopy. So yeah, it was just really cool learning all of that. And I do remember also, like in organic lab, making the ferrocene, synthesizing that, and I can like still just like smell the ferrocene. Actually, it's like a memory I never forget. So yeah.
Okay, thank you, Sherry. Riley?
So yeah, my undergraduate research has definitely been a super memorable experience, but for the sake of diversity of answers, I'm going to go with the other answer I thought of, which is ironically every experience that I've had outside of chemistry. And the reason that I say that is because being at UW-Platteville has allowed me to have such a broad range of experiences, from I did a minor in math to computer science to I do performing arts as a hobby, to the 3 jobs that I hold with the College of Engineering, Math, and Science. And all of that has helped me to gain a lot of skills that I was then able to bring back into my chemistry coursework. I know right now I'm taking physical chemistry, and a lot of the skills I've learned in my math classes, like statistical methods and linear algebra, which is a class on matrices, have I've just been able to apply them so much. And with my job tutoring, I have basically been taking general chemistry every semester in college, so I've never been allowed to forget it, and that has been very useful because these concepts will come back again and again. And so I think one of the main advantages that I've had from my degree, and one of the main things that I'll always appreciate about it, was the huge range of experiences I've got to have and how they've all been interconnected and served to make me a better chemist than someone who just took the standard chemistry coursework and that's it.
Okay, thank you. Stephanie?
Probably the most memorable part of any of my chemistry classes that I will never forget are the interactions with the professors. Sherry already mentioned this. We're a very small school, so you get to know your professors, and whether you like it or not, they get to know you too. And you're sitting around waiting for a chemical reaction to occur, and you start chit-chatting, and you're all adults here. It's a much different dynamic than it is in high school. And these people, these scientists, are some of like the most amazing people to look up to, and you can talk to them and be like, hey, what about this thing? And they can be like, yeah, that's cool, what about this other thing that I heard about? And it's just a really interesting dynamic to just be like in a room with like a doctorate and just have a conversation. I don't know, I'm very many other situations in my life where I'll be in that situation where I can like pick the brains of someone who got a PhD in chemistry, which is not an easy thing to do. So that's probably one of the things that I will look fondly back on Platteville, is all of the funny, the crazy, the whatever you want to call it, conversations that you get with the professors here at Platteville.
Thank you, Stephanie. That's nice. So our students actually, being a chemistry major, you have opportunities to do research with our professors and get paid. You have opportunities to do internship, opportunities to work in the department, and many other opportunities. So I would like our faculty members to talk about those opportunities. And Dr. Cornett, you go first.
Oh, sure. So,
do you have slides?
Yeah, a couple.
Okay, I'll stop this.
Yeah, so we do a lot of research that's very applied to support the field of forensic science, and that we need to have statistics when we go to court now on some processes that we may or may not have really thought about. So just one of these really quickly I'll share with you is looking at ignitable liquid residues on clothing. So we were contacted by, along the way, 2 different agencies to ask us if we knew anything about the fate of ignitable liquid residues when they went through a traditional laundering process. So yeah, it's washing and drying time. So students did a lot of washing with different styles of washing machines, and really learned a lot of GC mass spec, which is one of the key, if not the most essential element or instrument in the crime lab on the chemistry side of things. So we do things like look at how ignitable liquids deposit themselves on clothing first to understand that. So in this case, we might not realize this, but there's a lot of petroleum products in our clothing when we buy them right off the shelf, even if they're 100% cotton. In this case, we actually see the lubricant, petroleum-based lubricant called a slip coating, used to coat the needle as it's making the garment itself. So what we see here is a spectrum of that. And now it's on the bottom so that we can compare it easily to an ignitable liquid residue. So on this particular slide, we see Coleman camp fuel, or a light petroleum distillate. located on the upper axis there. So you can see all the components and compounds that make up that camp fuel. And here's an example of one research question we're able to answer. Does it make a difference if you have like a traditional impeller agitator type washing machine, like perhaps a speed crane, versus the new high efficiency front loading HE types? And we were able to show, no, it doesn't make one bit of difference at all. The ignitable liquid residue will persist through the washing cycle, or cycles, as we later found out. But what we did find is that as soon as those clothes touch the dryer, we begin to rapidly degrade ignitable liquid residues. So in this particular case, we see that one cycle through a typical residential drying cycle completely wipes out the residue. And I'll stop sharing here. The importance of that is that in both cases, they were capital murder trials. And in one, we were also able to do a research project quickly that showed that exposure to ignitable liquid vapors, the person claimed that he was running back in to save his wife and child, when in fact the time it takes for the vapor to deposit on his clothing would have incapacitated or killed him. So it was pretty obvious that he had killed them and set the fire. So we do research like that. It's like I said, it's very applied, and sometimes it works its way into casework.
Okay, thank you, Dr. Cornett. Dr. Hamilton?
Yes, hello. I'll share the screen. Okay, I see this nanomaterials research screen. Well, so we work with a lot of students on nanomaterials research in chemistry and the borders of chemistry and physics and engineering. And there's nice teams of students that you come in, and we like to start with freshmen in the lab, and you work with a more senior student and you get more and more advanced until you get see what you're doing and you move on. I'm going to play this and it should run. There we go. And so here you see a whole bunch of students that have been here, and a few of them went on for PhDs, some are accountants, some are engineers. And now we have a big program working with NASA on nanomaterials to develop coatings for this sunflower-shaped star-shaped telescope, because what this is going to do is fly 50,000 kilometers away from a Hubble telescope and block the starlight while you look through it, and so that they can image planets around distant stars. But if they had 100 specks of dust around the perimeter of this, that would scatter more light from the stars than would come from the distant planets around stars far, far away. And so they needed us in Platteville to develop a polymer to paint on the razor blade edges of this thing that's 40 to 100 meters in diameter, so that when you peel it off before space launch, that there is no dust particles there at all. And with that, then you could watch planets go around distant stars and spectroscopically use your chemistry to identify whether or not there's oxygen, ozone, and water on distant planets. And this is one of NASA's major missions. We continue to work on this. And further, it turns out that a big problem for NASA and the European Space Agency is to get rid of biological contaminants when they're going into space, so that we don't contaminate the other planets or moons We're working with the Europa mission, Europa Clipper mission that's going to the moon Europa. And we don't want to send bacteria and fungi and things from Earth and people up there. And so we developed a specialty polymer just this year that we were able to show with the student work that you can put it on and peel it off and it removes all the bacteria and fungi. And so this is a field called planetary protection. And so we're really like Men in Black, and the students working on this kind of call themselves planetary protection scientists. And so if it's one of the examples of the things that you can do in our chemistry department. So anyway, thanks for listening.
Okay, thank you, Dr. Hamilton and Dr. Raja.
Yeah, let me get the slide up and running. Maybe Ian should go first because Ian's going to talk about. Can Ian go first?
Okay, so Ian, you go first.
Sure, I can talk here for a sec. Can you see my slides?
Yes.
Yeah, so I just want to give kind of a little slightly broader overview of some of the research here. So all of the chemistry majors here in the chemistry department have to take at least one credit of research, which will be directly with one of us faculty members. And I mean, most students do more than one credit, but that's one of the requirements. But in terms of just kind of overall examples, Dr. Hamilton's already talked about his first contact polymer research with NASA, and Dr. Burnett talked about some of the ignitable liquids research there. Some of the, just a couple examples of other projects that are going on in the department. So Dr. Rabbani, who Riley works with, this metal organic framework stuff for kind of a variety of applications. One's toxic metal removal. Dr. Pugh does some plant biochemistry work for developing drought-resistant seeds. So that's some kind of exciting stuff there. My personal work, which is where some of these pictures here are shown. So we develop dye molecules to use essentially in photochemistry. So you shine light on the dyes, and then they absorb that light energy and convert it into chemical energy that we can use to develop new chemical reactions. And there's a lot, as everybody has kind of mentioned, there's a lot of opportunity for really, direct research with faculty and a lot of research opportunities. This doesn't just apply to students who are already here. So there are new freshman research scholarships that are given. I've got kind of a link here, but normally it's for your first year after arriving in Platteville in the fall and spring. There's like a $500 per semester scholarship that goes to pretty much putting you in the lab and doing some research. And there's a number of different projects that you could choose from to kind of jump in and work even from the very get-go. So there's really a lot of us who are doing research in a number of different areas. There's also opportunities for summer research. So a couple of things I'll mention. We have a very nice summer undergraduate scholars program here at UW-Platteville. Students get paid about $4,000 in stipend, and then there's an additional money that goes towards their project, and it can be in a variety of things. I have a student doing this kind of new reaction development photochemistry with me this summer, and we're kind of making some good progress there that I'm hoping we'll be able to publish in probably sometime next year is my hope. But in addition to things like the Summer Undergraduate Scholars Program, several of the faculty, depending on our grant money and other things that we have, we'll just hire summer research students. So this summer I'm hiring a student to do research with me for the majority of the summer. It's basically just like a regular 9-to-5 job. It's just you get to be in the lab, you get to apply the classroom knowledge now in a laboratory setting, and it really helps complement that. So that's another opportunity there for work over the summer here at Platteville in chemistry. And then also we've got just student jobs during the semester in the department, primarily things like chemistry. We have a chemistry stockroom that students work there, helping to set out our general chemistry and upper level chemistry lab supplies and deal with things there. And of course, Riley has also mentioned tutoring. We've got a lot of tutoring in the department. So those are just some kind of overview of examples of research in the department. And I think I'll send it back to Raja if you are ready now. I'll just stop sharing. But that's just a brief overview of stuff that's going on in the department in terms of research.
Thank you, Ian. Roger?
Raja, you're muted.
So I'm going to talk about what happens after you graduate from UW-Platteville. So now you've graduated from UW-Platteville as a chemistry major. That's awesome. So now what? So where do chemistry majors go? Where do they get jobs? And so this is a lot of this information I've gotten from almost all the information I've gotten from the American Chemical Society. The American Chemical Society is I think the largest professional science professional society. So it's a lot of members. And so you can see, and this is from 2015, I think it sounds like every 5 or so years they do a chemistry census. So this was from the last time they did a chemistry census. So you can see that most people who get a chemistry major, they end up in industry. Some end up in government, a large portion end up in academia. So you can see that there's a large portion in academia as professors like me and the other people that are talking here, or in industry. And you can see that this is the median full-time salary for those graduates in those various fields. So you can see, like Stephanie was talking about wanting to go into industry. And that's usually why a lot of chemists want to go work in industry, because the median pay of chemists in industry is so much higher than in a lot of the other fields. You can also see that based on where you live, you can get different pay. And so if you want to stay in the Midwest, you can see that depending on what level of degree you get, you can make a really nice living. And if you want to go out on the West Coast, the pay changes a little bit depending on cost of living, right? So this is just to tell you, yes, you can make a chemistry major is a really good way to get a really good job, making really good money. It's a very marketable major. The other thing I wanted to talk about is bachelor's versus master's versus PhD. So you can see the starting salary. So this is from 2015. They didn't have the masters. I guess they didn't have enough master's students to survey in 2015. But you can see the starting pay for a bachelor's versus master's versus doctorate here. Bachelor's, it's an awesome job, and we'll go over some companies where we send a lot of our students. The doctorate level is obviously a little bit higher. So depending on what level of degree you get, that'll really affect where, what kind of job you can get and what kind of pay that job is going to give you. Very marketable degree overall. So these next couple of slides are kind of wordy, but so I'll just kind of take you through them. I thought this was interesting because this is kind of showing where different degree majors end up overall. So you can see that with a doctorate degree, you end up on more of the R&D side. And with the bachelor's degree, you're doing more of the analytical analysis in a lot of cases. You're working in applied research, but you're probably doing a lot of the analysis for a lot of that research. So this is just telling you, kind of breaking down where a lot of people go get jobs with the different degrees. And so the doctorate degree here is leaning more toward research and development. The master's degree is kind of a sweet spot there. Because you're not going to school as long as a PhD, you can kind of be between different fields there. You can also see that if you want to stay in as a chemistry major for long periods of time, your pay will increase, which is great, right? So you can see with a bachelor's degree, after working in the industry for 10 to 15 years, you're getting to pretty high pay. And again, With the doctorate degree, that is an accelerated pay scale there. And the master, with the doctorate and the master's, the pay scale accelerates as you're there in industry or in your job for a longer period of time. So there's a lot of information there, but really the whole point of that was just to tell you a chemistry degree is an awesome degree. Come get a chemistry degree because you will be able to get a really nice paying job that will allow you to grow and make a really nice living for yourself. A lot of our majors recently, when they go into industry, we send a lot of our majors to different companies in the Madison area. So this one got cut off: Exact Sciences and Promega, Covance and PPD. So we sent a lot of our students to Covance and PPD. We sent a lot of our students to Sigma Aldrich and Verona. These companies, the Promega, PPD, Covance, and Exact Sciences, you would probably be doing a lot of the same techniques that you would be doing if you were in a in a crime lab, GC, mass spec, HPLC, things like that. So even if you come and you want to, and your forensics or your criminalistics, that degree is still really marketable for all of these companies, and these jobs are really good. You get to come live in Madison if you want to live in Madison, but there are jobs all over the country in companies of like in this same ilk. And then I quickly wanted to talk about graduate school, because I think this is something that I don't think I knew about when I was in high school or even in college for that matter until I was about to graduate. So let's say you don't want to go and work in industry. Let's say you want to be in academia. Let's say you're like, I want to go to school some more, which is what all of us here, a lot of us here wanted to do. You're like, yes, let's go to graduate school. So let's talk about a master's degree, which is what Stephanie is going to get. The cost is variable depending on where you go, depending on the school. Some schools you can actually get it paid for if a lot of schools, if that's the terminal degree at that place. Other schools, depending on the caliber of school, it can range on the order of, $5,000 to $10,000 a year. Just depends. It can take 2 to 3 years, but just like we saw, that master's degree does give you a higher starting pay, a little more responsibility. So what about a PhD? If a master's degree will cost anywhere from $10,000 to $20,000, how much does a PhD cost? That's what's awesome. You get a stipend. You get paid to go to get a PhD. A PhD is not free in the sense that you have to spend your time, but you get a stipend to go get a PhD along with health insurance. It can take 4 to 6 years, but again, after that 4 to 6 years, the job you get is of a higher starting pay. And also, I just want to mention the PhDs, those are the ones who are the project leads in a lot of projects. If you want to be the person who discovers or develops the next big cancer drug or the solar harvesting material, that a lot of those people who are doing that work are PhD chemists, right? So PhD chemists allow you to go in all different areas. And I just also want to mention that a chemistry degree is like in the middle of kind of the sciences. Like, we have physics on one side and biology on one side, of chemistry in the middle. And so we're able to span into all kinds of different programs. And so, Stephanie said she was going into polymer, which is like a materials type area, but with the chemistry degree, you're able to go into that, right? So there are PhD programs that chemists can go, that our majors can go into: material science, materials engineering, environmental science, biochemistry, chemical biology, molecular biology, etc. We're a very, very diverse field. Finally, I just want to end on, a lot of students come in wanting to go to med school or vet school, etc. Does a chemistry major make a difference? And the answer is yes, it does. In terms of med school, we can see that if you are majoring in the physical sciences, 48% of the students majoring in the physical sciences who apply to med school get in, compared to the 42% of the students in the biological sciences. The only other field that is as comparative is the humanities. Now, there's not as many students applying from the humanities, but again, being a chemistry major is a really good major. It makes you competitive for so many different things. So, and at UW-Platteville, as you've seen, we have a lot of opportunities for you to do all kinds of cool things. So that's all I got.
Okay, thank you, Dr. Raja. I just want to ask any questions for our students and professors. So any questions here?
Thanks for coming, Alyssa.
Yeah, so I just want to thank you for attending today. Thank you. And thank you for sharing and Riley and Stephanie for joining us today too. Okay. Thank you, everyone.